Sorry about that. So, directions are still those crazy directions we've seen like past couple of days, even before break. Factor each expression completely. Okay? So, let's just take a look here at number 1 and see what we're kind of dealing with here. I'm going to kind of zoom in a little bit there. Okay? This is a special situation. Okay? And you'll see it's special. Well, maybe you'll see it's special. Maybe not. But I'll kind of describe why it's special here. Okay? So, first of all, is there a GCF that we can factor out here? No, there isn't, right? Okay. Is this thing a trinomial? No, it's a what? Binomial, right? Because there's only 2 terms. Okay? All the factoring we've been doing has either had a GCF we can factor out, this one doesn't, or it's been a trinomial, like you saw here in the warm-up, right? Where we were able to take those 3 terms, right? We broke up the middle term and then factored by grouping. But here, we can't only factor by grouping, but there's also no middle term for us to break up. Right? So how are we supposed to factor this thing? Because it actually does factor. Well, there's no middle term, right? What number do we use to represent nothing? Or none? 0. 0, right? And so we can write this, we can rewrite this equivalently as m squared plus 0m minus 16, right? Isn't that the same thing? We can give it a middle term of 0, 0m. Okay, we're going to give it a middle term. Now do we have a trinomial? Pretty much, kind of. Yeah, I mean, yeah, we could probably get rid of the 0m and simplify it to a binomial here. But I mean, we kind of have a trinomial now, and we can use that strategy we've been using here. So we'll do 1 times negative 16 there and get negative 16. And now we're looking for 2 numbers that multiply to what?
4 and -4.
That multiply to what? Negative 16 and add to 0. Right, and then Sky, exactly right. It's 4 and negative 4, right? 4 times negative 4 is negative 16, but if you add them together, they cancel out to give you 0 there. Okay, so I'll make that 0m become 4m minus 4m minus 16, like that. Question?
After we do this, can I go back one?
Yeah. Okay, group the first 2, group the second 2. Okay. From that first group there, Dylan, what can we factor out?
First group.
What's that? An m. And what will be left behind when I take an m out of here?
M plus 4.
Yeah, very good. Okay, Dylan, what about the second group? What can we take out of here?
-4.
Very good, negative 4. Good job. M plus 4 as well will be left behind. And so they both have an m plus 4, so we have m plus 4, m minus 4. Okay, just like that. Pretty straightforward, I hope. Pretty straightforward, I hope. Okay, let's go to number 2. Try that one out. Take a look at this one. Okay, you'll see it's similar setup. Right? We have our variable squared minus and then a number, just like that. Oh, if you want to go ahead, Tyler, go ahead. Okay. Similar setup here. So again, we can see, okay, it's a difference here. Let's go ahead and add in a 0x minus 9, because again, there's no GCF to take out, right? We can't factor any GCFs there, so let's just put a 0x in there. Okay, we'll do 1 times negative 9, so that gives us negative 9. And so we're looking for 2 numbers that multiply to negative 9, but that add to 0. So what are 2 numbers that multiply to negative 9, but add to 0? 3 and negative 3. Okay, and so we'll break up that middle term there. Right, break up that middle term. Group the first 2, group the second 2. Okay. Matt S., what can we take out from this first group here? An x. And what will be left behind? A 3. It was x squared. We took an x out, so what's going to be left behind? Nope, an x. So it's 3 times x. When we divide that by x, when we pull the x out, we're dividing. 3x divided by x is 3. But an x squared, remember, that's 2 x's being multiplied together. It's like x times x. So you divide one x out, you're left with an x still behind. Okay? Matt, Matt S., what can we factor out from this group right here? There's a number. What divides negative 3x and negative 9? A negative 3. We're going to factor out negative 3. And so it leaves us with x plus 3 then. Negative 3x divided by negative 3 is positive x. Negative 9 divided by negative 3, positive 3. And we both have an x plus 3 in common. So it'll be x plus 3 times... Anybody? What's the last step? X plus 3 times x minus 3. And there it is. Thank you. Yeah. Okay. All right. You guys go ahead. Try number 3. Number 3. Give it a try. Number 3.
After I do number 3, can I do that?
When Tyler C comes back. So going to try number 3. You have the right idea, but great. Good job. Good job. So 49 times negative 49, does that make negative 49? You want two numbers that these numbers need to multiply negative 49. So what two numbers multiply to negative 49? Good. On the right track here. Good. That's good. Take it to negative 7. Yes. Good job. Good so far, Sean. Yep. I can? Yeah. You want me to?
No, for
I got FCA twice.
no, but like somebody is working at this missing.
Well, there's no set for like a couple, like tomorrow's the last day I set for a while. So I might get you a little work on it in class or something like that.
Wait, what are we gonna do?
They have like park assessments, so all classes are lengthened. 10 minutes. So 90 minutes instead of 80 minutes. So we get an extra 10 minutes of fun together.
All classes?
All.
What about the part assessment?
People will take those too, if they have to. Are you in English 10?
No, not even. I haven't said it English.
Are you in? I don't even speak English, Mr. Wick. No, you do. Algebra 1, ours will be at the end of this school year. But some students are taking Algebra 1 test right now, soon.
The answer 10 plus 7.
Mr. Wick. No, because Tyler's not back, and after Tyler, it's Mark, and then after Mark.
And then can I just 7
After Dylan comes back, sure. Oh, okay. Well, you might want to put your number in now because you'll probably have to go by the time everyone else is done. So, just in case, you know. All right. Anywho, folks, here's your answer. B plus 7, B minus 7. Okay. Now, has anyone started to notice a little bit of a pattern here with these problems? Yep. Mark did. They're all easy. Okay, I hope so. I mean, that's if they think that, that's good, Okay? So there is a pattern here, and in fact, these kind of problems are known collectively together as a group called a difference. And why do you think they're called differences? What about them makes it a difference? What about 1, 2, and 3 makes them differences? They all have what?
Different letter.
Think mathematically. What does the word difference mean?
Oh, they're all subtraction.
Subtraction, right. So they all have subtraction, and it's a difference of squares. Okay? Difference of squares. Okay? 1 has m squared minus 16. 16 is a perfect square of what? 4 squared is 16, right? X squared minus 9. X squared is a perfect square. 9 is a perfect square of 3. B squared is a perfect square. 49 is also, it's a square of 7. And you can see how these factor. They factor very regularly, right? 16 is a square of 4, so you have m plus 4, m minus 4. 9 is the square of 3, x plus 3, x minus 3. 49 is the square of 7, b plus 7, b minus 7. Okay? So there's a pattern here, okay? If you have a squared minus b squared, that equals a minus b times a plus b. Okay? That is a difference of squares. You may use that shortcut to help you factor. Okay? You can use that shortcut to help you factor. Difference of squares. Now, before we start about number 4, 5, 6, and 7, I want to jump down to number 8 real quick, because how is 8 different than the other problems on this paper here? Mark, Dylan, Alex, what's different about number 8 than the rest of these? We have addition instead of subtraction here. So, but it's an addition, it's a sum of squares, right? It's a squared plus 4. Let's see if we can factor this one. So I'll put in that middle term that's missing there, the plus 0a. Okay. I'll do my lead coefficient 1 times 4. I get the number 4. And I'm looking for two numbers that multiply to 4 but add to 0. Bless you. Looking for two numbers that multiply to 4 but add to make 0.
Positive 2 and negative 2?
Do they multiply to positive 4 though? Right. So what ways can we multiply 4? Well, we can do 1 and 4. We can do negative 1 and negative 4. We can do 2 and 2. We can do negative 2 and negative 2. Do any of those combinations add up to 0?
No.
They don't. So what do we say about this? It doesn't factor. Okay? Number 8 does not factor. Right. So a sum of squares does not factor. A difference of squares, difference of squares does factor.
I have a question about 5 and 6. So you know how this is 4 there?
Oh, 5 and 6 you said.
Yes.
Oh, okay, we'll talk about that in here in a second, yes.
Can I do 16 real quick? Well, actually,
Can I see the top of your paper? Thank you.
So you want to look at number 4, 5, or 6 here, Alex?
I actually did all of them. I kind of went ahead.
Okay.
And for number 4.
This way?
Thank you.
Yeah, no. For number 6.
Number 6.
So I knew the square root of 16 before.
Okay.
And then I wrote, but then I saw there was a
H to the 4th, right.
So then I was like, maybe I should cut that number in half.
Yes.
And then I got H plus 2 and H minus 2.
Yes, we'll get to that. Yes. So yeah, and again, let's skip I guess we do number 4. Let's do number 4 here. So let's get to some of these more complicated things here. Okay, believe it or not, right, 9v squared minus 100, that is also a difference of perfect squares here. Okay, these are perfect squares. So, 7 is similar, but it's got an r it's to the 4th instead of squared there. Okay? So actually, let me see here real quick. Do these all have coefficients?
Dylan.
That's kind of frustrating. Okay. So, are you good, Ms. Mulcahy? Yeah, I can scoot it up
Yeah,
now?
thank you so
Okay.
much.
Mm-hmm.
Sorry.
Nope, that's okay. So 9v squared minus 100. So let's again take a look at this one here real quick. All right, because now we have like a coefficient, right? All these other ones, it was just m squared or x squared or b squared. So let's go ahead and try this one. See if that kind of a minus b, a plus b thing still shows up here. So let's see. So again, we'll do the 9 times the 100. We'll get 900. And I'll go ahead and put in that 0 middle term there that we don't have written, but I'm going to write it in now. Okay. And we're looking for two numbers that multiply to 900 but add to make 0. Sweet.
900?
9 times negative 100. Oh, it should be negative 900. Thank you.
Okay.
Two numbers that multiply to negative 900 and add to make 0.
Negative 900 and...
You're on the right track, though. 30. It's 30. Yeah. Negative 30, positive 30. They multiply to negative 900, and they will add to 0. And so we'll break it up here. 9v squared minus 30v plus 30v minus 100. Okay? Group them. And what can we take out from that first group there? A v. Anything else? A 3, right?
Oh, yeah.
So 3v minus 10v there, I think. Yep. Okay. What can we take out from the second group? What divides 30 and 100? 10. So again, 3v minus 10. And so we have, oops, I forgot a 3v there. There we go. 3v is what's there. So they both have a 3. Oops. Sorry about that. I made some errors here. It should be 3v parentheses 3v minus 10. That should be 10 parentheses 3v minus 10. They both have a 3v minus 10, so we can take out that 3v minus 10 in common.
Wait,
and we'll be.
Not 10b or is it 10b?
It's not 10b. I apologize. I made a mistake there. It's supposed to be just 10 minus 10. And so we get this. Okay. Do you see the difference of squares here again showing up?
Yes, sir.
Yes? Okay. So the 9v squared becomes 3v and 3v, right? Because the square root of 9 is 3, and the v squared becomes just a v. The minus 100 becomes minus 10 plus 10 because the square root of 100 is 10, so it's minus 10 plus 10, like that. Okay? So difference of squares, we break it up into the square root of the first term minus the square root of the second term, and the square root of the first term plus the square root of the second term. Okay? So let's take a look at number 5, and Alex is on the right track there. Maybe you guys can see it too, right? Okay? This is going to factor as well. Okay? It'll be x squared minus 6, x squared plus 6. Do you see it? Right? X to the fourth becomes x squared times x squared. We have, then 36, minus 36 is the minus 6 and plus 6 there, and that's going to factor just like that. Okay? We can only do this because these are a difference of two perfect squares. X to the fourth is really just x squared squared. 36 is 6 squared. So you can see there's the x squared, there's the 6. Okay. Like your number 6, h to the fourth, okay, that's really h squared squared minus, and then 16 is really 4 squared. Okay, so this will factor to be h squared minus 4, h squared plus 4. Okay. And there's actually one more step we can do here. There's one more perfect square. There's one more difference of squares here, number 6. What's the one more difference of squares we have right here? What's the other difference of squares we still have here to factor?
2.
Yeah, we have this h squared minus 4 right here. This can factor to be then h minus 2, h plus 2. And this can factor to be h squared plus 4 still. That's a sum of squares, right? That doesn't factor, so we'll keep that the same. But this one factors still to that as our final answer. Okay. Okay. So With the remaining time in class, I'm going to let you guys get started on your assignment. Okay, so here's what I'm going to give you. All right. Unfortunately, I'm going to have you do... Yeah, go ahead. I want you to do 10 through 14, please. 10 through 14, please. So 10, 11, 12, 13, and 14. Okay, and this will be homework if you don't finish it, right? But you got time to do it. I think you guys can probably knock it out if you know what you're doing, right? If you just get it done here real quick. 10 through 14 for your homework. Okay, I want you to go ahead and get started on it now. So Alex, go ahead. 10 through 14. 10, 11, 12, 13, 14 on that paper right there. What do we call this? Factoring trinomials 3. 10 through 14. It's not what we've just been doing. No, I'm sorry. These problems are a little bit... It's still factoring, but it's not factoring difference of squares. For some reason, we did all the difference of squares. Well, there's one more difference of squares there, I guess, and number 17, but we'll try that again. I just wanted to show you that difference of squares, I guess. Yeah, there's a few more I could have assigned. I don't know. Anyway. Give it a go. Oops, sorry about that.